All right, guys, I got a few more kids on quarantine here, so I want to jump into and show you what's going on with peardeck today, in case you need anything extras from the uh, lesson here. So 32, a lot of kids thinking 4 and 8 here, and 8 is 4 and 2. Oop, 4 and 2. So what I'm looking for is pairs, and once I see a pair, I can stop. If I happen to make this into a bunch of 2s, that's fine. Right, this would be a set of 2s, that'd be a set of 2s. I have to multiply them back together to get 4, and then I have square root 2. So that takes care of my numbers, right? Anything left over is going to be put on the inside. If there are multiple, they'd be multiplied. M to the 7th, 6, 7. All right, so you get 1, 2, 3 pairs. So that makes M to the 3rd with 1 left over. All right, I'm not going to write out 11 of these. Right, if I had 11, how many pairs do you have? That's 5, and you have 1 left over. All right, and because you guys are Algebra 2 and getting ready for the SATs, right, we also talked about using the absolute value, right? So if I go from a square root, so if I go from an even to an odd power, I have to say that these must be positive. To say that they must be positive means we're going to use the absolute value on them. Okay, so anytime we go even to odd. So I'll point that out today as we work through these. All right, next one we have is 75, hopefully using 3 and 25. Because when I think about 75, I think about 75 cents. That's something that most of us have used sometime in our life, maybe the vending machine or whatever. So I get a pair of 5s and I get a single 3. I have x to the 8th. Okay, so 8 divided by 2, that's kind of the way to think about it here. I would have 4, 3. I'm going to get one of those and 1 left over. And you're like, hey, Mr. Tola, what are you doing that for? Why'd you write a 1 in there? You don't usually do that. Here's why. Because when I see that 1, it's obvious to me that it's odd. And then I remember to do the absolute value on just the y term. All right, next one we have going on is 20. All right, so instead of using 2 and 10, I want to try and think about using perfect squares if I have a factor. So 2, leave some space, square root 5. X to the 10th, well, that's 5 of those. And y to the 5th, I can get 2 of those with 1 left over. All right, so who needs an absolute value? The only thing with an odd power, so that would be x to the 5th. All right, so this is one thing we pointed out. So let's say we needed z to the 6th as well. So I get z to the 3rd, and then you're like, oh man, now I need this. Well, that looks really weird, right? So this is one thing. It's a case in the SATs where you probably write things out of order. So we'd say 2y squared, absolute value, x to the 5th, z to the 3rd, absolute value, square root 5y. Just to make sure that it doesn't look confusing. I tried to color code it so you realize that the red ones go together and the green ones go together. Okay, but this is one thing, and it's really for standardized test prep. Other than that, we're not going to use it too much more together in class. All right, whoa, we got an extra number here. Okay, what you do is completely ignore it, right? So we're going to go with 3 and, no, we're not. No, we're not going to use 3 and 15. Let's use 5 and 9. So I get a pair of 3s that I have to multiply by that -3. So it's -9. Okay, remember this is all multiplication. What's left over is a 5. I got y cubed. So I got y and y, first power. So I'm going to add my absolute value on the y on the outside. Okay, so that was the only add-on, right? So this -3 was times the pair of 3s, right? So I had -3 times 3. That's how we got the -9. All right, intro into where we're going with this. You could simply multiply these together and tell me 350, and that would be super impressive, but not required at all. Because once you put it together as 350, guess what you have to do? Take it apart. So let's just do this. Let's go with maybe 10 and 7. Well, that's 5 and 2. So I get a pair of 5s, so it's going on the outside. And I get a 2 and a 7 left over. Remember, this was all multiplication. So it's going to go back together as 14. No variables, so I don't have to worry about any absolute values here. All right, next thing we'll take a look at is, so if you could multiply last time and impress me, say, oh, that's 350, there's no need to do it here. Okay. So if you want to impress me, I'll tell you how to do that in a second. So I'm just going to rewrite this as 40 times 56. We just reviewed exponent rules. So no hesitation here, it's x to the 6th. All right. Now, here's the part. If you want to impress me, go ahead and give me a common factor of 40 and 56. So 5 times 8 and 8 times 7. Now I have a common factor of 8. I'm going to multiply it by -6 to get -48 on the outside. What's left over is a 5 and a 7. Again, I'm multiplying things, so it's 35. And x to the 6th gives me x to the 3rd. How do you like that? Ooh. All right, there we go. We have to put our absolute value on there because, like I said, today is our special day on that to try and get that. So if it shows up later, you're like, yeah, I remember something about it. Evens to odds. All right, we cracked the code in class. By all means, if you want to do that, go ahead and pause. Otherwise, we're going to keep going. The other thing we're leading into is some division. So I like to divide whatever I can here. So this is 4a squared. The other thing I'm going to do is go ahead and separate these. So I know that this can be done in two separate problems. So I get 2a over b squared, and I'm going to get my absolute value bars here as well because a ended up to the first power. All right, so this is all a lead-in so that we can see how to deal with some multiple choice type of questions. So for this one, we want the smallest whole number x such that 20 times x is a whole number. Well, sure, I could plug and chug and I could try 4 and then I could try 5 and do all this. But you know what? Like we just learned how to do this. So let's go with what? 4, 5. So it's 2, 2, and 5 and an x, right? Well, I already know that the 2's are going to come out. So what other number needs to go in here to make sure that I get a whole number, which means it's a perfect square? Well, that's 5. Right? It's kind of the useful part of all this. All right. So for this one, we showed you division. So first thing I'm going to do is say, well, that's 14x, and I'm going to do the square root of it. So 14 happens to be 2 times 7, and there's an x. All right, what are we after? We are after 7 on the outside and 2 left over. So who needs a pair? The pair has to be the 7's, right? So that means x would have to be 7. Now again, this could be done through just plugging it in, trying to figure out which one works, but I think it's a lot easier to use the knowledge that you're growing right now to answer the question. Same thing here, 180, it's not a big deal. You break down 180, you won't. So it's 18 and 10. So that's a 9, 2, 2, 5. I get a pair of 2's, 9, that's a pair of 3's. Okay, so we're saying that this has to become a whole number. So it's got to work out. So right now I have 5 over x. Well, if I want this to be a whole number, which one makes it work? It can only be 5. Who cares about the fact that it's still square roots? No big deal. All right, so that's where we're at with it. And we're going to apply some of those things. That's what we did in class. All right, in your OneNote, you're going to find 61K, and we'll catch up on how to use your calculator, or you can Google it. Those are the things we worked on today.